doesn't know how to save oops. It doesn't know anything about GC, just a random call. But we have to have a save point there because we need to do GC stack walking potentially. So the Oopmap had an oop saved in RBP, and I looked all over the place, and as far as I could tell, RBP should not be considered alive after the call, so that should not be possible. But apparently RBP is always assumed to be saved. So the GC will always assume that that information is available, which is kind of surprising because
the frame pointer.
Sorry?
It's the frame pointer.
Yeah.
Special register annotation.
Yeah.
Which was odd because C2 didn't care, but C1 did, and the interpreter did, and so it went back and forth as to whether or not we cared.
Yeah, so looking at the current code, right, in the AD file it says, oh, it's never saved. And then there's some special handling when scheduling calls that says, oh, if you're doing a runtime call or what I'm adding, a quote-unquote native call, just assume any register is being killed by this call. So don't leave oops in them. And then the Oopmap had an oop in RBP anyways, so it tries to look what the callee saved for it, and there's nothing there, so it would crash. There's a comment somewhere that says RBP is always saved in a well-known location, so we can assume it's there. But this assumption also implies that your callee is a Java, pretty much Java method that stopped at a save point, and you're walking back across that save point, and you can update the RBP location along the way, which is not the case in my case. So the assumption that RBP is always saved seems kind of strange to me. Yeah, so that's my Friday afternoon. Pretty frustrated after spending so much time on this.
Yeah. Okay. I recall completely revamping this stuff at Azul. The frame crawling. The major goal I had was to be able to always crawl all frames all the time at any point, cheaply and well. It was the whole thing with taking high frequency interrupts and doing stack crawling to grab stacks, and along the way we sorted out all the frame handoff, including what to do with RBP. And of course, we were doing it with our Azul systems, which didn't have any such thing as an RBP. So we did a more generic solution, and that rescued RBP on the Azul flavor, but obviously it didn't work, never happened at Oracle. Well, sorry I had to go through that. I recall it being a mess up at the time, and I recall it being a mess up for no good reason. But there was a bunch of conflicting things running around at that time that I didn't have the whatever you want to call it. I didn't have the energy and the correct political skills to sort out. There was a war going on between C2 and C1, and the runtime stack crawling was try to catering to both, and they had arguments over how it was to be done and why. So a lot of things didn't happen that should have long before I left that I did at Azul. And in the meantime, the stack crawling and therefore the stack layout and therefore RBP, they were all screwed up and kind of frozen in place in time. Sorry you had to go through that, but that is old history for me. Hi, well, okay, so we're 5 after. We've been actually going for a little bit. We got a update from Matt, but let me do my spiel. Although we've got all hands here. It's being recorded. I'll put it up on Twitter and YouTube about an hour afterwards. If you don't like recording, bail out now. I think everyone here is like, almost all of you are old timers, so who cares? Yeah, so for fill in for folks, Matt just gave us a dump that said, here's why the hell I had a brief trying to crawl stacks had a slightly different use case, and the comments lied compared to the code and what the meaning of RBP was. Is that a fair summary?
Yeah, just spent several weeks of looking at pages and pages of codes that seem to do the same thing, but in a different algorithm, in a different place, especially with regards to computing liveness information, which happens in several places. So basically, at a certain code offset or at a certain node in the IR, compute which registers are alive. And if they have oops in them, then you need to save them. I kind of lost my train of thought there. It's been a long week, I guess.
Sure. Yeah, that whole code and the concept and the shit you do with it, I like to say it's not rocket science, but it's extremely detail heavy. And you can just get lost in the weeds so easily. Like I said, the rewrite I did at Azul went a long ways for cleaning that stuff up, but it is not, okay, Heinz?
Yeah, he's a good looking guy, huh?
Yeah.
I'm trying to assault my camera here. It did the screen share accidentally. This wasn't on purpose. It wasn't on purpose.
It was very disappointing, that's for sure.
Yeah, off by one bugs can actually bite you when you're dealing with the stack.
Oh, it's like an infinite number of them. There's so many.
Oh, glad to hear it's not just me.
Off by one. No. So one of the things that came out of the learning at Sun was the need to very heavily assert things that are actually very difficult to assert for here. And then a bunch of technologies around how that assert might look, right? So Sun came up with the blah, blah, blah lot flags. There are 27 flags that say something, something a lot. And they make the rare case common. And of course, you run 10 times slower because the reason the rare case is rare is because it had to be made rare so you could not do it all the time. It was too slow. So you run big Java web servers over the weekend doing all kinds of heavy load with these lot flags on. And generally, you can get your crashes earlier and quicker. It's better that way. But the thing that came out for me at Azul was finding another way to simplify the stack crawling thing. So I guess a couple other lessons came out of Sun there. One was you could actually write sort of machine independent stack crawl code and separate out what it means to have a frame, to have a next frame, to have an end of frame. So have a frame iterator, or stack iterator, I guess, and what it means to get a Java value mapped to a stack location. And so in that mapping somewhere there was, we saved things here and there, and then that turned into a stack offset, and where do you find it? And so you could make those independent so that the machine dependent portion of the layout varied from how you accessed it. So it was the right high level APIs. And prior to that time, I'd never heard of anyone even thinking about doing such a thing. And coming into Sun, the first go around certainly was not. It was all handwritten, just grovel around in the stack. Separating those, even if you're only doing x86, is a huge benefit in terms of cleaning out the complexity of thinking about the problem. And then the next step I went at Azul was unifying. There's a bunch of things I did there. I unified all the stack crawlers in the system. You only want one, but we had, of course, one for the interpreter, one for C1, one for C2, one for the generic runtime, and a separate variation for if you're throwing an exception and crawling the stack and you're trying to unwind as you crawl. Like specifically Stack Overflow had its own thing going on that you didn't need, you could get rid of. There was a notion that everyone crawled the same way, and that in turn led to needing a way to, EBP or not, everyone either used EBP or they didn't. But as soon as you said, I want EBP because I only got 15 registers, now I have 14, I had to take a stack pointer, get a program counter. From a program counter, I get a length of a frame, and then away I go. And once you made that as a religious thing at every point in the world, life got a lot easier for stack crawling, and Oracle never went down that path. So there are lots of handoffs done at Oracle for stack crawling games, and when you're switching from interpreted to compiled, and compiled to interpreted, interpreted to native, and compiled to native, and native to compiled, every possible variation thereof, and all with exception throwing at every possible step. Not all of those transitions are all identically done. And you lead to these funny holes like you just fell into. C2 doesn't technically need a frame pointer. And I did that work a long time ago to free up on a 8 register x86. Stack pointer's gone, now down to 7. Frame pointer's gone, now down to 6. Like, holy shit. So I freed up the frame pointer long ago at C2. But C1 was using a frame pointer, and the interpreter's using a frame pointer, and the runtime expected a frame pointer, and so you had to have some sort of hack going on there around frame pointers. Part of the work at Azul was no frame pointers for anybody. And that meant everyone had to, you know, deal with stack. And C1 actually still, Azul at that time was using C1, and C1 used a frame pointer. So it went through an extra step to get a frame pointer at each step of the way. But C1 was not the high tier execution, so it kind of didn't matter. It blew an extra clock cycle on method entry to get a frame pointer set up. So, you know, the moral of the story there is this really is complicated shit. It's details all hell, and the bugs are horrific to go debug. So simplify, 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 and assert, assert, assert. I don't know what else to say. Well, there you go. So, you know, 10 minutes in, dead silence.
I made a nice little bug today, or almost wrote a bug.
Excellent.
I was refactoring some code, just goofing around basically, and I called the contains method on concurrent hash map by accident.
Sounds reasonable.
It does, doesn't it? Contains, right?
Yes.
But contains is contains value, not contains key.
Oh shit.
And, I mean, I've looked at concurrent hash map for the last 15 years, and I still didn't know that. I was like, what's this thing?
How big was the hash table?
No, it was just, I didn't even run the code. I mean, I caught it before that. I was like, why, like, what is this? And they put it in just to be backwards compatible with hash table, because hash table it contains. And
it's a linear walk.
Yeah,
Non-blocking hash map has a contains call. It's a linear walk.
Yeah, exactly, linear walk, exactly. And I had no idea about it. And so I was like, okay. and I tweeted it, and just to see how many people like true or false, right? And I'm getting, what is it at the moment? I think it's like,
You putting up a Twitter poll?
Yeah, that was always amusing because we get like 95% getting it wrong, you know. And yeah. it's like true or false. So you'd expect it to be 50-50, but no.
Yeah.
Hash map has a lot of sharp edges. It's the least reentrant object in the history of Java.
Yeah. 61%.
You know, if there's ever a side effect, of something going on inside concurrent hash map that touches the concurrent hash map, you're dead at that point.
Yeah, absolutely.
So,
they try to get off that with the.
I threw a one-liner in chat. I probably blew it, but I'm just saying, add the first 1,000 random bools using the standard Java util random. What do you think the sum would be? For I equals 1 to 1,000. Add the first 1,000 bulls up. Random bulls.
You'd expect it to be 500, right? That's what.
Yeah. Anyone else have any different answer? I'll give you a hint. It is not 500.
No, I'm just saying you'd expect it to be. I'm not saying it would be, but you'd expect it to be.
So you want to try a different guess? It's not. It's
547.
Okay, let me think about it. It's going to be.
And you're correct, of course. If Java util random returns something that you would kind of think is pseudo-random, you'd probably get something close to 500 plus or minus some standard deviation. But that's not what you get.
I think I saw it on Stack Overflow. I think it does, if I remember correctly, it does some rounding internally that turns out to have a bias towards one or the other.
No, it may, but that is not the issue here.
I'm just wondering about nextint 2. What
Well, it's me trying to write a bool. Nextint 1, nextint 2. I don't know what the number right.
Yeah. It's
In
something
C,
to
I
do
mean, a
with
Boolean
nextint
is
2.
an int, so you're good.
Right. I'm getting a 0 or a 1. Okay. So it's long enough. So the answer is 0. You get the first 1,000 random numbers between 0 and 1 are all 0.
Oh, really?
And that's because C
That's
sucks
hilarious.
so bad that it takes somewhere around several 100,000 before it starts to produce numbers that are mostly random.
Isn't it seeded with the time though?
For whatever reason, like if you look at the milliseconds times or whatever, those high order bits have not changed in decades, and they won't. So independent of where it came from, my experience running a random number generator, building random forest trees for a company doing hardcore math needing a random like number, is that Java util random really bites until you've run it many thousands, hundreds of thousands of random numbers before it starts to look sensibly random.
So that's interesting because years ago, the only way we could get Java random to be random without using secure random, which was its own nightmare.
Yeah, it's a different nightmare. I tried that one and it's a different nightmare.
Was we'd seed it with the date time, then we'd pick a random number of milliseconds, add some value to it, and of course the random number of milliseconds was always the same. And then we would spin producing random numbers until that time had expired. And the reason it created it semi-random is because the amount of spin that you do is based on a whole bunch of things, including because at the time, like on Windows, for example, you had a 16 point something millisecond granularity on the clock. So if you asked at the wrong time, it could be as little as 1 millisecond, or it could be as much as 17, and so you'd spin for a while, and then you'd actually start getting. But what they tell you to do now is to use the thread local random. It's dramatically better.
Yeah, there's a bunch of improved ones.
Okay, I had to try
random
it out.
is
I had
amazing.
to try it out, and I'm getting 471. So.
Well, good. So maybe it's been fixed. Roll back to Java 5. And
I'm not supposed to do that.
go to 6.
I think Java 5 introduced. I think Java 5 introduced self-erasure, so Java 5 no longer exists.
Okay, so go to 6. Somewhere I started at 6. I left the company at 8. It was still an issue, but by then we had flipped internally to like PGR, a pretty good random number. Whatever. There's one of these things, but we needed pseudo random so we could reproduce results distributed across a cluster. Couldn't even use thread local. We needed thread local, but we couldn't use the thread local.
They may be using Guy Steele's new algorithm. Before I left, he had just invented and patented a new, very cheap, not secure, so it couldn't be used for secure random, but it was dramatically cheaper than the previous algorithm that Java used for years.
Okay. Yeah, the pretty good random one is actually really cheap too. It's not pseudo non-deterministic like you were talking about. It's a little bit of that flavor. There's a spin in it. Every time you draw a random, that's usually not spinning, but it spins sometimes. And that.
So Java 6 is 525. So
okay.
I'm going to go back to Java 4 and 3 and 2.
I don't know. It wasn't that.
It'll take a while to go back.
No, it wasn't that far back because this was when I was at H2O. I even tweeted it, and it was reproducible reliably, and we were getting 0 for small randoms forever and a day. Thank you for running that number, though.
This is random equals new random. No, not like a seed of 0 or something like that.
I thought I was using random equals, system.millis.
Oh, okay. Which is standard, I guess.
Which I think is what, new random does.
Okay.
And, millis of 10 years ago, but that wasn't the issue. There was some initial seeding thing going on there. It might have been next random where I put in like 1, 2, 3 as the seed, or 1, 2, 3, 4, 5 or something. The low order bits were perhaps not huge. I'd have to go look that one up. Now you got me curious, because I swear I had an easy one-liner that blew out here. And I don't even know how to do that. This will be like, what is my first tweet in Twitter? Is there a way to roll Twitter back?
You'd have to ask our friends at Twitter, I suppose.
You have to, well, right now I'm doing it by the old-fashioned scroll back, and it reloads.
Oh, that's going to take a while.
Yeah, and it also seems to have stopped somewhere about 3-4 months ago and not loading, so I don't know. Dang. Okay, fine. Well, never mind. There you go. I don't know what I'm talking about.
But on the topic of thread local random, if you haven't looked at the implementation, it's quite amazing. Like, despite the name, every thread gets back the same object. And then there's some hackery to pull a field that's been mashed into Java-lang thread. And I was doing some performance testing, like simple thing, trying to write a stupid load balancer and just say, no, I'll just use a plain non-volatile int that I'm just incrementing as a stupid load balancer across threads. And then comparing that to a thread local random one, and thread local random was ridiculously faster than just incrementing a non-volatile int. There's just no cost. I can't say how good the random numbers coming out of it were, but just the performance was
so if
amazing. It's just free.
Right, if many threads increment a non-volatile int.
Yeah, it was on x86, so it was the same
cache line,
if it was volatile.
You get a cache line ping pong. That's pretty clear. Yeah. If you do that on a machine with weaker hardware, with those
fields is to pad them, right? Yeah. So all the fields are padded, but then also what they've done, which is really interesting, is the stripe 64 uses those fields as a real nasty hack in order to distribute the cells amongst the threads. So have a look at stripe 64, because they basically use those fields inside thread.
I gave that hack to Doug Lee.
Oh, is that your hack?
Yeah, well, it was the concurrent. I called it concurrent auto table, but it was me trying to come up with a thing that wouldn't suffer endless false cache miss.
Yeah, exactly.
So it just doubles an array and forces everyone in a random slot until you quit failing CAS updates, and that's it sizes the table according to the count of busy cores that are hammering it.
And the idea of sort of storing the fields and thread, is that your abomination as well?
Well, certainly the thing at Azul was we stored all these fields and threads, but the thread basis, the thread level storage that was outside the Java visible object were guaranteed on different places, right? That was base of the stack pointer. You take the stack pointer, throw it in a regular register, mask off the low order bits. That's your thread local storage base. That was a 1 clock. Here's your thread local storage. And it was thread local. You had an 8K buffer of whatever crap went in there, including random.
That's not normal Java thread local. You're talking about an internal.
Correct. No. This was the implementation for all the thread local games that were not the Java thing. Now Java util does what a thread does, what the fuck a thread does, and they went round and round. Some of that stuff we mapped into this hack I'm talking about, because you intrinsified it because it was too hot to let it sit around.
Yeah, back when I was doing the same experiment with thread local versus plain volatile, I also tried, thread local random versus plain volatile. I was also trying, okay, I'll put my counter in plain old Java thread local, which also lost big time compared to just plain thread local random, because Java util thread local has so much overhead.
Oh yeah, Java util thread local was like doing a hash table for every thread. Took the thread, went to the same hash table that everyone was in, found some structure. Yeah.
Well, now it's a hash table per thread, but it tries to clean up every time you do an insert. So there's it's not a full table scan on every new thread local, but it's basically a full table scan.
Okay.
So it hurts. So
the Azul version of the Java thread object was you went to the thread local storage. I was talking about the hardware level one, and you pulled up an OOP that was a pointer to your thread local struct. But now Java util thread local has got like some string to whatever mapping, and that's a hash table lookup. So yeah, they're doing cleanup on thread locals.
Yeah, they're just worried about leaking thread locals. So it's a lookup in a thread local. A lookup of a thread local is a plain hash map lookup, but a insertion of a new thread local scans your thread locals for any ones that can be discarded. And I don't remember whether it scans every time or 1 out of 10 times, but it's enough to be expensive.
Sorry, how does it know it can be discarded?
That I don't remember. But I just remember finding that and like, oh, that's why performance is bad, or one of the reasons performance is bad here.
Okay, yeah, I don't know why I don't even know what the semantics are. What's the semantics that says you can throw away? If I put something in a thread local, when can I throw it out? I assume the hash table goes when the thread goes, so that's just the lifetime is the thread lifetime. But what's the?
Yeah, I'm trying to remember the details, but I guess it's a fairly common bug that people put thread locals in and then forget to do the corresponding remove, and threads hang around for a long time, and you've got a leak.
Yeah, right. I assume so too.
So,
but then it's like,
yeah.
It's like a weak hash map or something, where you wait for a weak key and then you toss it because it's a weak key.
Yeah, it certainly sounds like. I wish I remembered off the top of my head, but it resulted in me writing my own replacement for thread local that said, no, like I know when to remove my things, and then it's way faster.
Right.
Yeah, each thread local key, I think, is a weak reference.
It's a weak key. Okay, so it's a weak hash map. And that's probably a standard weak hash map.
Not exactly. It's not a weak hash map as such, but it has a similar characteristics.
It's not a weak hash map?
No, it's not the weak hash map, but it's got similar characteristics.
Right. It's got a weak key, and they're scanning the key. Yeah.
Correct. Which also means that if the key gets cleared, until you actually use a thread local and add another thread local or lookup or something, your value might remain forever.
Yeah. Why isn't GC crawling those and wiping them out? That was the whole point.
No, well, GC will clean out the actual key, but not the value until the map is used.
Until the map is used. Right.
So
yeah, fine. Yeah.
So writing is the right solution, Mark.
The comment in the code says heuristically scan some cells looking for stale entries.
Exactly.
On every new edition.
Yeah, non-blocking hash map actually does something very similar for exactly the same kind of reason. Now that you've said that, I have to crawl some amount. Not on every one. I during a table copy, I do some crawl work to get the table copy to be completed, and that's how I delete old things. Yes, fine. Oh, what tangled webs we weave, right? Rather have something cheap and fast and simple, and somehow it didn't happen. All right. What's next? I'm hacking recursive descent partial grammars. I don't know.
I was doing that this week myself.
Oh, excellent. See, what are you doing? You're doing X to XCC here?
Yeah. Changing a little bit of grammar around the new expressions. We introduced virtual constructors this week.
So are you using a grammar generator of any kind, or is it all hand-rolled?
What's a grammar generator?
Yeah, a parser generator.
Yeah, I don't know what that is. I
Okay.
just write my own.
DSL describe the grammar, and a generator gives you a piece of code.
Yeah. No, I write pretend BNF, and then I write the parser.
Okay, fine. That's what I'm doing too, and I'm finding holes. So I'm back and hacking my BNF. And
well, holes, I'm sure there are people who would disagree with me on this, but if your language has no holes, you've probably not done very much. So I mean, there should be some, pause and ask yourself, is this ambiguous? Moments in language design. Otherwise, you're not.
I have plenty of those though, and I was wanting to get some tooling to come through and just, I can at least write a series of what I think should be parsable expressions and push them through and then edit the grammar. And I have a new thing I want to see that it works. And so I've hacked my grammar and do all the old things continue to work. That's where I'm at the moment. It's fine.
Yeah, so virtual constructors are pretty cool. The idea is if you have a type, you can ask it to new itself given a constructor pattern. Or if you have an object that already exists, you can ask it to, for example, for implementing cloning without everyone having to paste in a one-line method that says, return this, a new instance of this particular class. So you can drop that pattern onto an interface, and anything that implements that then has that virtual constructor contract, which means that any subclass that doesn't implement that constructor is a compiler error. So it allows the compiler to participate in the type safety of that design.
So why isn't clone just a top level? Everyone has it already. Like it's just an array copy of the object guts.
Well, that's a shallow copy.
Yeah, shallow copy. Yeah, exactly.
Yeah. So for example, we have immutability. So let's say I have an array or a subclass of array that contains maps with its values being, hash sets of, ordered lists of, like.
Yeah. On.
So some fairly deep thing, and I want to get an immutable copy of that, or I want to get a snapshot of that, right? So how do you do that? Well, in Java, it's really easy. You create a byte array output stream, then you create a data output stream on top of that, then you create an object output stream on top of that, then you write the object into that. If it doesn't fail serialization, then you read the object back out of the byte array by creating the input streams corresponding to the output streams, and then you've done your clone.
No. I just did.
That's how you do it in Java. You don't like the answer, you write your own language, right?
No. I just did the clone. Just call clone on the top guy. He shares all the pointers, and that's a shallow copy, and that's an immutable thing.
What?
Exactly, because you're immutable, you just clone the top guy.
Well, if you're immutable, you don't clone at all. Right, exactly.
I actually use this. Well, no. Yeah, if you're right. You don't even clone at all. Right. No, I want to make a new guy that's slightly different. I want to make the Delta version. So I make a clone of the new guy, the old guy.
That's right. And that's another thing that we do is we allow you to provide, say, a transformation function as part of that process. But the transformation function is going to look different if you're a map versus a collection, right? Just to give an example, or if you're a person versus a phone number, or if you're, a shopping cart versus an invoice, right? So being able to design an API like that sits on top of a generic functionality, yeah, you're right. Clone is handy. But if that's the only hammer you have, your nails are all going to get bent.
No, I'm misunderstanding the need to do what you just described, which was a serialize a deep copy, or the semantics of serializing.
You don't serialize it to serialize it. You serialize it because that's the only way that Java has a deep copy functionality built in.
Okay, okay. I went a different route at H2O.
Yeah, I mean, Heinz, any comments? Like, have you ever had to do a deep copy of something?
I'm still trying to figure out this random stuff because I've tried it with Java 1.0 and it didn't compile. And 1.1 also didn't compile. And 1.2 gave me 500. So
yeah, right. Find my tweet because I wrote it. It was one of my first tweets ever. It was like the second or third tweet.
Yeah, I'm trying to figure out how to search all tweets now. So
I want to know too, right? And I totally had this one-liner that did this thing.
Yeah, of course.
Lots and lots of people were like, "Holy shit!" and they go rerun it, and sure enough.
Yeah, of course. So you're talking about deep cloning.
For Cameron, I totally did deep clones at H2O, but I did it by writing bytecodes. I used Java Assist, and we would spew objects into a network buffer and send it over the wire to another cluster member who would unpack it. And that was all. It was any Java object that had reasonable constraints on it. You couldn't have it locked because the lock wasn't going to flow over the wire and shit like that.
Right.
Yeah. So just a few thoughts about that. If you're cloning something which is mutable, you're looking for trouble if you're going to stick if that object output stream is going to be around for a while. But if it's just a temporary thing, like I want to make a byte array, then that'll work. And it works so nicely because of the hash table they've got inside the object output stream. So you actually aren't going to reduplicate the same object over and over again. So I think it's a fairly, it's not a bad way to do a clone. Like the official way, as Cliff said, is to follow the clone protocol. But like if you just want something to do it,
but if you want a deep clone,
fit
you're
good.
screwed with the shallow clone, right? I mean, that's the thing.
Well, yeah, unless the objects themselves implement clone.
Yeah, I would claim that you need to flag it. There are different use cases, and there are different reasons you want either one.
But if the objects implement clone, it doesn't call clone. You call clone on the outermost object, and you get a clone of the outermost object with non-cloned.
That's correct.
Innermost.
And I claim that is the correct API, and it should be labeled as shallow clone. There is a separate API that does not mention that says, make me a deep clone. But then you have a bunch of other rules you have to sort out. And in this deep clone mean I have cyclic structures internally inside my deep clone. I'm going to do a deep clone.
And there's one other thing that you forgot to mention, which is that clone can't be implemented in Java.
That's correct.
So, you know, like, hey, if you're willing to write assembly, fuck, everything's on the table.
Oh wait,
you are actually willing to write assembly, so that's
but
fine.
I didn't write assembly. I wrote Java assist, which is I wrote Java code,
right.
strings, Java strings that are pasted together by Java assist and outputs.
So now my point is, I want you to do that again, except one line of code to make a shallow clone. If it weren't in the language, how would you do that?
I'm sorry, if I wanted to do clone,
let's say you wanted to implement clone in Java and it weren't implemented as an intrinsic or as a native inside the VM, how would you do it?
Oh, I'd have to do the Java assist thing.
That doesn't fit in one line. Give me one line, right? And that's my point, is that there's
you make a library call and you call the one-line library call. But the actual implementation of clone in the language itself is not a one-liner. In Java is not a one-liner. You're correct. So you make a library, and then you call the library, and the library is your one-liner.
And I'll give you another hint on this one. You know, we have yet to have a class that ends in the word factory, even though factories are extremely useful, and we use them all over the place, right? So, like, it's just well, you asked, like, like being able to have virtual construction is incredibly handy. So. Because it's a type safe method call, if you will. It's not a method. It's a instantiator. It's a factory, but it's a type safe factory for any type, for any signature.
Okay, I just gotta, Mohammed, give me a tweet, and this is a video of mine. It's not the tweet in question. The tweet in question was very specifically code in the tweet. The Java code fit in the tweet. I don't remember what that tweet is. What the hell? So that's fine. I'll look it up in a minute. But the code in question fits in a tweet. And it was, in fact, I believe it was like, it didn't have main or class, but the entire method was cut and paste for code outside of having a main. Fine. So yeah, fine. So Cameron, one of the things that I did at H2O was I used clone as an intrinsic all the time. And I kept copies of things lying around so that I could clone them quickly. And that was my answer to very high speed. I want to move things over a cluster. So I had to pack them into some serializable format that was way the hell denser than Java util serializable. I was faster than the fastest Java serializer on the planet at that time, measured by all kinds of people. And one of the things they'd done in there was compress the shit out of things as while you're writing it, because the network overhead exceeded all other costs. But unpacking meant I loaded a byte, which was, or 2 bytes, it was your class ID, looked up an array, grabbed a base object, cloned it, and then called the unpacker, which took the network byte pointer and had unrolled field stores as Java sys emitted code. So every class had a parallel class that was the serialized deserialized that was auto-generated behind your back. You never saw it. You wrote a Java class and you did your normal Java things. Right. If you happen to use a pointer to this object on another cluster, then as part of the handshake that you didn't do anything about, this guy would get squished and unpacked, and the squish logic was part of the background class that got auto-generated.
Yep.
So
Pretty cool stuff.
I get sort of where you're coming from.
No, I wasn't suggesting anything to do with serialization. I'm saying that just happens to be the only hammer. Well, you pointed out another one. You can generate code on the fly. Yes, so you can.
In the land of Java, to do this, you generated code on the fly.
Mm-hmm.
Yeah. And you cached the code. It was only a one-time hit. It was all invisible. Part of
yeah, I mean, incredibly powerful. I mean, we did similar stuff. I mean, we even migrated lambdas and stuff like that.
We had totally migrated lambdas around. Absolutely. This was H2O. It was running. You couldn't move the data. The data was too big. You had to move the code.
I'm quite acquainted with the concept.
Yeah, fine. Yeah. Sorting out the new language things, and now that you've said that and you got my head thinking about things, I've already had different things that would do with serializing things, but I'll probably go visit clone. I'm going to have a shallow clone in my language as an intrinsic, and that's just going to be part of impartial. That has to be there.
Mm-hmm.
But then if I have a shallow clone, does it make... You're saying I want to have a reified type object, and I want to take a nuance, a reflective type object. I haven't sorted my head around that piece.
Yeah, we have all that. Yeah.
Right. No, I don't, and so I have to go think my way through that here. So figure what I can do. But mostly I don't have reified types. So everything gets, I'm auto typing every possible
with
thing.
a lattice.
Yeah, the magic lattice determines every possible type on the planet pretty magically. Up to some resolution, but if you have objects that have fields that have variable types in them, he'll tell you the range of variability, but that means you still have to have runtime type info somewhere in there. And then if you have runtime type info, immediately you have all the reflection questions that come around. And some of those I know how to answer directly, and some of those I haven't thought through. So
I think the example you were just giving of how you generated that code on the fly is a pretty good reason for having reflection, that type of, even though it's a very late binding in the sense that you're generating code. I mean, being able to drive that off of RTTI is invaluable, because otherwise you have to load the IR, the structures,
There are some languages that basically kind of sort of hand you the IR and say, go to town.
Yeah, C# does that now.
I'm sorry?
C# has that capability now.
Somebody else too, let's say Julia or somebody. And I kind of was headed down that path in my head, but like I said, I haven't gotten that far. There's a variant there that says, I have all this information. A lot of it is useful and should be safely shareable. So what can we do here that I can expose it to you in a way that's usable by you and not broken?
Right.
That didn't break the safety of things.
And by safety, you mean security or something else?
I mean, no, I mean, not security in that sense. I mean, language safety. So you can't generate bytecodes that do something broken. So in my land of auto-generating code for Java, if fields were declared final, I had to cheat to get the final field set. So I'm constructing on the remote cluster an object that has a final field from this guy. Well, packing it into the buffer, but when you unpack, I have to set a final field. Okay, how do I set a final field? Well, I have to build in your normal Java class a constructor which takes an argument which can load a final field. But I'm not touching your Java class. Your Java class didn't have a constructor that took the right argument to stuff a final field. It's a standard serialization problem. So I used unsafe. So I generated code to hammer in over an unsafe field.
Mm-hmm.
Okay, that is, as soon as I have to use unsafe, I have broken all safety. Now, I haven't broken it because I'm careful, but I hand you unsafe and say peek and poke RAM. Safety schmafety, it's all gone now.
Right.
So can I do this without unsafe? So one of the rules
I'm pretty sure you can overwrite finals with reflection too.
Same problem.
Which of course is still unsafe, but you're not using.
It's better. You're correct. It's
Pure
better.
Java.
It was too slow for my uses, so I didn't want to do reflection. But I could do reflection. That would be better in the sense that I wouldn't let you just peek and poke arbitrary memory, which turns into, you know, I just smashed the VM's brains out or whatever. But instead, I'm changing a final field, but as part of a constructor process that's not known in the language as a constructor process. It was safe.
Yeah.
I'm building an object from whole cloth, and then I hand it outside of my construction process. So I don't care how the fuck I built it.
So you can do it in a constructor with a constructor pattern, but what you have to do is basically have the final field use a virtual method to initialize itself, where the you basically have a flag where you make a branch between the first time it's constructed versus the deserialization route. So so then but you have to change the bytecode of the class that you're, so
yes, I see.
which isn't bad because you can do that on the fly when it loads. You don't have to do that on disk.
So what I'm doing with my new language is I'm claiming I have final stores, not final fields.
Mm-hmm.
And a field is not final until you do a final store. And once you do a final store, no load shall ever see any other value. And therefore, I can stall the final updates sort of arbitrarily. And I have to do flow things to figure out that you have a final rate.
With var handles in Java 9, you can, it's possible to write final fields. Bit of a hack, but you can do it.
And when you say it's possible to write, so we've already mentioned unsafe and reflection. How is this more or less safe than those options?
Well, okay, so normally when you use var handles and method handles, you can if it's a read-only field, if it's a final field, you can only read it, you can't write it. But there's a special type of lookup called Impul Lookup. It's got this really like boring name, you know. They don't want to call it unsafe lookup. They call it Impul Lookup, so nobody would want to use it. And if you use the Impul Lookup, then you can actually write final fields, but only then. Otherwise, you can't. But I like your idea for final store rather than a final
But
field.
you added another lock, and the name of the key is Impul Lookup. So we just unlock that lock, and we're back to
exactly. But the thing is, it looks so boring. People are like, oh no, that's boring. We're look at Impul. It's like boring stuff.
It's totally supported though. You can, if you have a method and you set accessible true, and then you unreflect that method to a var handle or a field, I guess, then it will use the Impul Lookup, and that's the supported way of doing that. So
Yeah, sure.
yeah, but it will do all the module access checking if you're on Java 9+. So it's less of
Those
a.
modules are really quite horrible. I wrote a book and I thought I should use Java 9 for it, and those modules they just cause so much trouble. Just, you know, the reflection and dynamic proxies and modules, like horrible.
I'm very
Not
happily
OSGI at least.
using them. I'm sorry, what did you say, Cameron?
I said at least it's not OSGI. Someone's going to hate me for saying that, I know.
Oh God! Wait, am I thinking of Corba? One of these older.
It's not Corba, but came out of yeah.
Wow.
Yeah. So what we did, well, we have immutable types, but there's the exception on immutable types is that a field can be lazily loaded. So say, for example, you have a 10 megabyte blob and it's immutable. It can still calculate its hash code and store that value off, so it doesn't have to CRC it every time, right? So it's the hash code becomes a lazy property. I'm making it up as I explain, but so lazies can populate their value once, as you said, it's kind of a final. What'd you say? A final
Just like
store?
final store.
Yeah.
This is like a future. I'm hearing you say it's a future, right?
Well, in this case, it's a lazy, but we implement lazy and future the same way. They're both mix-ins into a read-write var. So read-write var might be a property, a local variable, element in an array, etc. It's something that could act as an L value in the language. Think of it that way. So you can decorate the L value with an annotation, so it actually mixes its code into the L values code, because obviously every location in memory is a class, right? If it holds
Not
an int,
obviously, but this is where you're at.
yeah, if it holds an int, it's a class of something that holds ints, right? So
Yeah.
you can mix your code into the class of something that holds ints, and then you can prevent more than a single store to that in your code. Obviously, that gets expensive memory-wise, but in reality, none of that actually has to exist. So, but the idea is with the immutable is that you can, with an idempotent calculation, for example, you can calculate it even after the object's immutable. So the next time you access that value, you get the same one. But the interesting thing with immutables is they can exist lots of places in memory. So for example, if you pass an immutable from one thread to another, it may copy it. Or if you pass it from one container to another, it may copy it up the container hierarchy. So you end up with a situation where if you haven't already calculated that lazy, we'll call it a field. We don't have fields, but pretend. If you haven't already calculated that lazy field, it could actually be calculated in theory differently across different domains of execution.
I mean, I'm sorry, how is this helpful? I'm missing something here. If I have a field that I'm expecting to be immutable, I expect the same value for everybody?
Right, which means if you need a field like that, you have to calculate it up front. Let's say that calculation is hugely expensive.
Okay.
Say it's a cryptographic hash, whatever.
Something expensive. Yeah. Okay,
fine. Something you only need 1% of the time.
Yeah.
But so we have a term for this in mathematics. Not that I know anything about math, but we call it idempotent.
Okay.
Or impotent, depending if you're impotent or not. Yeah. So idempotent sounds better than impotent. So yeah. So
But wait, so you have a thing which is idempotent, and and therefore you could calculate it multiple times in different places, but you only need it once. And as soon as you get one, you cache it. That's exactly a future. So now, okay.
No, a future is a pending, as opposed to a future is a pending. It's a promise, right? There's a difference between a lazy and a promise.
Well, future doesn't have to ever be calculated.
That's correct.
But it memoizes. It's written once and memoized.
That's correct. Yeah.
Okay.
So I can. Sounds like the string hash code.
Right. Yeah. Exactly. So a hash code is a perfect example.
Yeah. It's memoized. It's idempotent. You're saying because it's idempotent, you can compute it more than once.
No, not just
right.
That.
If you have to.
Because it's idempotent, you can actually, you don't get data races on it because it's the same.
Yeah.
Same answer.
Yeah.
But it's only an int, so.
You can atomically write the same value into the same field, and no one cares that it's the same thing because you got the same answer.
Exactly.
Which in an immutable world, that's true already all the time. If we all start from the same inputs, they're immutable. We all have the same things. We're going to get the same answer out every time.
Well, in the absence of stimuli, yes.
Yeah, in the absence of any stimuli. Yeah, fine. I do that coding pattern manually all the time.
Yep.
That's hash consing, if you will. I usually throw in the hash table and throw in the special lookups, and I'm doing this in Java even now for my implementation because it's usually more efficient. Because it's fucking faster despite all the crazy overheads. But then there's no boilerplate support in Java, so never mind. I'm about to whine about Java again.
What's also interesting about the hash code is they've recently, Java 14, I think it is, they changed it a bit so that if the hash code is 0, they only work it out once. So they've got another Bullion value, which they set. Because that's something else. Obviously, you don't want to accidentally get to a value which you have to then work out over and over again for idempotency.
You mean for string or for anything?
Yeah, for string. For string.
Yes.
I assume that's because it's a potential denial of service attack.
Oh, Anything like that has to have a
sort of.
like,
It's
yeah.
If it's 0, it's going to work out again. So it's you have to send very long strings to the server.
Right. So I would claim that the correct answer here is that if it's 0, you should just set it to fucking 1. And
There's
backwards compatibility.
Yeah, they can set it to 1 backwards compatibility. Also, if you start at 1, for example, then you could get data races on the string. So they can't start at 1 because I said, why didn't you start at 1?
What do you mean by start at 1?
Or start at something else.
I wouldn't. What do you mean by start at 1? If it's 0, you haven't computed. If you do the hash calculation, it comes up with 0. This is go ask Josh Block for poly auto ungenome or whatever the hell. He's got some funny one that he knows. It's a 1 word that goes to 0. You just say it's 1 at the end of computing a hash. You say, oh, hash equals 0. Use 1 instead. Done. Now you set it 1 time to 1, and your hash is a 1, and now you never compute it again. I'm confused about what race you're talking about. There's no start at 1. You start at 0. You compute the hash. If the hash is 0,
I hear you. It's but as Cameron said, backwards compatibility is like the holy grail there.
Separately, backwards compatibility. Yeah, fine. And if you change string hash code values, you would blow some people. I know people who do perfect hashes, for instance, and
yep.
Java puzzle.
I need to get running.
I'm sorry.
So have a lovely weekend, you guys.
Yeah.
And see you maybe next week, hopefully.
Yeah. Yeah. You too.
Bye.
And is that the actual picture behind him? Maybe not. He lives on Crete, but I don't think he lives on the water.
I like more Millennium Falcon background of Mark.
Thank you.
So I have this theory that says if I was to play that video back, every time your head moved, I could pick up the smear where the fill-in is lazy and slow and start to paint your actual background and come up with, what is really behind you.
One of my virtual backgrounds is my actual office, but a clean version of it. That gets really confusing when you get the smear and it kind of lines up to the what's it?
Yeah, see, I'm doing videos for class videos for teaching classes, and so I have to have a clean background. So I'm experimenting with this sheet hung behind me. I need to sort my camera so you can't see the wall outlet and stuff like that. But that's my, it's not my office behind me anymore. It's actually my living room behind me. Never the office, it was always the living room. Another time, a few years ago, there would have been kids playing Nintendo games behind me. But that's past. Sadness, somewhere between happy and sad. Yeah, it's all good, fine.
Did you get a new camera as well? It seems a little bit more crisp.
I did. Cameron gave me a freebie. The COVID, hey, bye. The COVID hit, everyone switched to Zoom. Amazon ran out of cheap cameras. I couldn't get a camera from Amazon that was anything under $40 had more than a month wait. Anything after that was like well above 250 for a camera. And it's like, oh, fuck it. So I waited a while. Then Cameron said, no, I want to get this thing rolling. So he sent me an El Cheapo throwaway.
What?
Yes. Want me to go find it? I have it.
It was like $100 20 years ago.
20 years ago.
Cam, did you remember to remove the malware from the camera before you sent it?
Oh, absolutely not. Just
Too
check out
late.
some of these pictures.
And it was a nice.
Why is this green light always on?
Yeah, well, right. It was a nice low-res camera. It's good enough to get the job done. And then a month later, supply caught up with demand, and I was able to buy a better camera for a reasonable price. I did. So I don't know. It might have been 20 years ago. It might have been $100, but if it was a 20-year-old webcam, it wasn't 20 years.
It was probably 15, though.
Oh, wow. Well, then it might have been 100. Yeah, that'd have been pretty high res for 15 years ago. So I have a $50 or $60 camera that's pretty high end now, medium high, I guess. But I couldn't get one a month ago or 2 months ago because Amazon was just In fact, I think I tried earlier, after a month or maybe 2, I tried, and it was a month delay, and I got a cheap ass $10 camera that was no better than one that camera had sent me. So I finally got again. I got a better mic. I don't know. There's nothing expensive here, truly.
So what are you teaching?
These no fluff, just stuff guys want me to do a bunch of 10-minute videos, a whole lot of 10-minute videos. And it's all the usual stuff, but chopped into 10-minute chunks. So like, you know, here's a JVM and what's in it? Well, we all know what classes are, but then I go break down the 100 things that are in a class you never thought about. I actually should talk to Heinz, make sure I'm not missing any big parts. And what's in a heap, and what's in the JIT, and what's in the runtime stuff, and that's 10 minutes, you know, 2 minutes a pop, right? And then 2 minutes on, I got 2 more on the JVM I'm going to do, where I'm going to do a little deeper dive into some of the parts. And then 3 10-minute chunks on JITting, and a couple chunks on performance code writing, and a couple chunks on CPUs and hardware level thinking, cache lines and bandwidth and fault sharing and virtual calls and the like. Where's your performance go at the low level? I got like 20 of these I got to do. So I'm trying to get set up to where I can churn them out.
Well, if you get bored, you know, I can really help you with that recursive descent compiler, and you can write my back end for me.
Well, there you go. Mostly I'm looking for a quick way to, I was going to see if you were using a tool. I was looking for a quick way to validate that I didn't make a new hole when I closed the old hole up.
Antler is, I've gotten a lot of good feedback from people using Antler. I've never used it.
All right. Yeah, I was just this morning thinking about, do I want to do this with a tool or not?
And there's a fairly new one, newer than Antler, that I've also heard some positive stuff about, but I cannot remember the name of it off the top of my head.
Right? That's old.
No, none of those. I think it's built in Java.
Oh, well, it's a little more convenient to use, but maybe I don't care. And what I want is like a fucking interactive experience almost.
Right, and there is a website that lets you like paste something in and then it spits something back out. I don't know if it's built on one of these.
I don't even need the spit out. I want to put a grammar in, put a string in. Is this accepted by the grammar? And what's the parse tree?
Maybe it was called jparsec. I believe that's also a fairly popular parser combinator library in Java.
Parsec. Well, it shows up on Google pretty quick. The Google letter, build parsers in Java, GitHub, blah, blah, blah. Available in Maven. Tell me more. Operator precedence grammar, error message, okay, this is recursive descent parser combinator framework written for Java. It's an implementation of the Haskell parsec on the Java platform. Oh, interesting. Well, there you go. So I run these things. Go find this stuff out. Yeah.
I don't think that one allows you to define the grammar and then pass that in as a string. That is more API-like. The last time I looked at it, I think Antler just allows you to define the grammar as a string and then pass that in, and it will figure everything out. But I don't think this one does that.
Oh, okay. So you have to like, you said API-like.
Yeah. So
here's some slides too.
I remember trying it out and having to do something like declaring arrays of delimiters and then later on feeding into some kind of builder thing.
Yeah, I mean, I'm in the zone where if I can make it happen with make, I'll just put it in and hit my magic go again button in Emacs and then edit the file and hit the go button.
Does anyone try Java CC? I've seen a couple of people talking about that one.
As a parser generator? CC sounds like
Java CC.
What the hell?
So it's a
most
Java
popular parser generator for use with Java. Dun, dun, dun. Okay.
I think it's based on the Yak design, but I've not used any of these.
Yeah,
So.
bottom up, which I don't care. Oh no, just a recursive descent. Okay. Da-da-da. And does this? I see. Has some BNF. I don't know. Okay, I'll stare at these. This is the right answer though. Yeah, this is one of these. I don't want to spend more than a couple hours at it because that's all it's going to take me to debug my grammar anyhow. But if I can throw something together that I can hit a button and edit the grammar and edit a list of strings and have it puke out the.
Yeah, I think there's an online grammar checker that'll
Right,
tell you
that's
what
what I
the
was
errors,
figuring.
what the errors are, but I can't remember the. For some reason, I want to say that Matt posted a link to it before. Come on, Matt, where are you?
Yeah.
Matt.
Online grammar checker. Yeah, it's a recursive descent. Not this time, he says. Yeah, this unfortunately, grammar checker hits me with a billion things with spelling and English grammar and not BNF. It's all good. Yeah, so in the language of AA, where I can go induce types, an array allocation looks like that. That just says make me an array of size 3, and I'll tell you what type it is. But then if I want to look up, I can do that, which says first thing up is make an array, and the second thing is get the 0th element out, which will be no, which is fine. But like the grammar for that's starting to get like,
Okay. Can you do Arraylist rules where you declare the elements as well?
Yeah, anything can be have a type added to it. So colon and a type name gives you a type.
Yeah, but I mean, this is still an array of length 3. It's not an array with one element that is 3.
No. Oh no, if you want to do the initial constructor, you have to put comma in there. That's an array of length 1 containing a 3.
Ah, okay.
And that's because I have to have a comma to say that you're making a tuple. And as soon as I see a comma, you're now a tuple, and I build a tuple, and then, oh, it's inside an array. So you pass the tuple to the array constructor, and you get an array of the elements. And that's the typing, and the actual implementation does the obvious smart thing, but the typing is make a tuple, pass it in. It's like, where's your ambiguity? Sorted all the ambiguity questions. I got this ambiguity one sorted out a while ago. Okay, so enter a grammar, and so I'm going to take their example. This is the thing here, and what do you do with it? Oh, I probably have to hit the grammar is, language is unambiguous. Some sentences, the grammar. Oh, I see. This is like a grammar checker.
Is that good?
Actually, it is. I mean, I have a BNF that I've handwritten in ASCII, in an ASCII gram that I could clean up and throw into this thing and just see if it has any obvious, you're screwed up this way or that way. I'm all happy to go that. Standard colon vector bracket int bracket v1. Oh, curly versus round. Yeah, so I claim standard colon vector bracket int bracket was already exceeded my threshold of pain, and I'll shoot you if you make me write that. Curly braces for me are always a function. So everywhere you see a curly, you're guaranteed a function, and that's sort of no questions. So it's unambiguous that way. And then, I don't know, after that, parens is either grouping or a tuple, depending on the comma. If it's no comma, you're a group. It's just a standard grouping thing. And if you've got a comma, you're building a tuple. Right. And for me, I need the comma, just like they do, but I use round braces typically for grouping. Standard lists also, yeah. Yeah, and then bracket deduced. Yeah, but I don't like the angle brackets on types. I want the colons of types, the angle brackets. But then deduced automatically is pretty easy even in these kind of cases. Yeah, and I'll deduce the same thing already too. But yeah, fair enough. If I want to have like a variable length a variable length, like an array list, Java array list, standard vector, then it's not going to be a primitive. It's going to be a language. It can be a library thing, and so there'll be a name there, standard vector, standard vec or something, probably standard vec, yeah. And then it'll take a tuple for construction and it'll deduce types. So very, very similar syntax. This is what I'm heading for that kind of a thing. It'll probably be more like, I don't know about standard vec, parens, something more like that. Or standards library, but it's actually just a struct and has a field called vec, which is a function call which produces a vector, takes a tuple as an argument, that's the tuple. And it is not incorrect. It is not a mathematical vector. So we can have those arguments too. Now, this is a language. It's not a mathematical notation. Dun, dun, dun. There's a lot of fun stuff. So why? So they're using colon, colon. Yeah, okay, I have a different answer. I have way fewer syntactic constructs than C++ does too, hugely less. Like I don't have colon, colon because I'm just using dot because it's just a struct. Std is a struct that contains a bunch of top level primitives. And .vec is just a field that's holds a function. And that function has got the constructor for building a thing in it. And you pass a tuple, and it takes a tuple arg, and the tuple is then does whatever it's going to do. What else he's got in there? He's got bracket, int, bracket. Does anyone like that kind of typing there? The bracket, the angle brackets for types, as opposed to colon, int?
Which one do you mean? The
well, it's a bracket, double bracket, or angle brackets.
yeah.
I want to put optional typing. So here, standard list deduces double automatically. So standard colon list. But if I don't like it, if I have to go do something, I did a bracket double. But I don't need to in this context because he's deducing double. That's great. So optional, you have optional types. Great. Angle bracket for optional types versus colon, right? And actually, I like my shorter thing, so I use DBL. This.
Yeah.
Colon for the type.
So yeah, but here, is the std list a double or is it a list of doubles?
In the syntax I just wrote down, I gave you standard list was a double and not a list of doubles.
Yeah. Okay.
So in fact, for me, it would be a function that's going to return a list of doubles or an array of doubles. So how about this? Standard list is, if I have to type the function, it's going to take a tuple and return me an array of doubles. It's not what you want here. I'm fooling around. Takes tuple, returns an array of double. That's a function declaration.
Yeah, makes sense. I think that both the colon and the angle bracket syntax makes sense.
And I take colon F64 as well as double, both for the same exact thing.
Yeah.
Because I take colon F32 and colon int 8 and int 16 and int 32 and int whatever for types. There's a little type language there.
I think both work. I think Kotlin and Python go with the colon syntax. Java and C++ go with the angle bracket syntax.
For Java, for generics. For Java generics.
For generics.
Yeah. I'd rather have the colon. Okay, fine.
Yeah.
How does the colon end up looking when you have a nested type, right? If it was a list of map entries of string to long.
Right, there's a nested type right there. You could argue it doesn't look good or it looks bad or worse. So I say colon.
The type name inside the square brackets.
I've gone back and forth, and I'm willing to go back again. if you put the type name in the bracket, then I can't tell you the type of the size operator, but the size operator is not exciting to have a type on it. Typically, I demand it being integer already.
Is that for kind of a dependent type style?
Well, right. So totally constants can be a type. So that's a type that says I have a constant array of constant length 3. So now I have 3 as a type, and I can totally have a type 3. That's fine. No, I have a default int that I'm going to declare as int 64. Did you have like the C int is variable size according to the hardware? Best current hardware.
So I'm thinking more about the API design here. It's particularly common in C APIs when the first question you have when you open a page with interface is which int is which. Because oftentimes int can be an error code return, int can be a size of a variable, int could be option for API to use different socket type, etc., etc. It's especially in networking interfaces for sockets. Everything is an int. Just like in scripting languages, everything is a string.
Okay, no, wait, back up for a second here. You mean int as a identifier token? As opposed to
int, literally as in int type, literally type int in C.
The int type in C, yeah, I have lots of int type. Yeah, but you have names on them, right? You have.
Yeah, you do. The names are often status or flag or selection, which is still pretty much
the programmer's choice on how he names the names, right?
Well, you can nudge the choices in the programming languages. I'm not super inclined to.
Give me an example. Give me an example of a name that is not so informative. Sorry, a function signature that's not so informative because it's reusing int in places that it needs to not.
Just a moment, I'm looking for a tweet.
Yeah.
But generally speaking, you get into trouble with int and with Boolean because, let's say you have a method that takes 5 Booleans, right? So it's like, what's the order? And if your IDE isn't, so I actually made this mistake this week. I got 2 Boolean parameters in a constructor mixed up and bit me in the ass.
That's what you're asking is instead to demand a unique set of types in a row in a signature so that you get a stronger, quicker abort for failure to get them right. And I claim that the only way I've seen that work well is if you have named arguments in a function call. So if you have 15 ints in a row that represent uniquely different things because I have 15 options, but of them all, most are randomly, rarely done and all taken for defaults. I want to have named arguments in the function call. I got only half of what you wrote there, Matt. Look at return types here and I'm waiting for the return here.
Yeah,
boom, int, yes.
So notice that almost every single return type in the socket API in Linux has a different meaning. Just pretty amazing if you think about it. Some of them are status code, some of them are size, some of them are the file descriptor for the socket that you have opened. To me, this is identical to what scripting programmers do with string. This is basically the moral equivalent of stringly typed API when you opt out of the type. I mean, it's almost the next step would be just using a void pointer all over the place, but it's pretty close already.
Right. So I'll let you name an int, give a name to an int, like gallon as an int or a float. Probably gallon would be float. Meters versus yards, so NASA doesn't lose another spaceship, right? You can put a name on an int. So if socket wants to be a socket numbered named thing, then you can declare a type that's socket num. Let's see if I can do the syntax here.
Yeah, since you're using float, NASA will lose another spaceship anyway because it'll have rounding errors.
Well, fine.
Anyway,
And the types you can declare, are they independent or are they like aliases like in C?
They are independent. So if I declare socket num is assigned a colon int, socket num is now a type. So then I can say a socket num is the return value. To use the C syntax, this is not my syntax. Socket num is the int domain, da, 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 da. So instead of returning int, it returns a socket num, which happens to be valued at range of values acceptable as an integer, but it only goes in places where a socket num is declared. There's a free cast away from socket num to int, but toward a socket num, you have to ask for a socket num. So if I declare I want to take a socket num, I have to have a socket num in the first place, so there's no free casting. But I want to like print a socket num, I'll declare an int and you'll just print an int and fine.
Maybe it's not the best strategy because of now you should propagate this typedef around all the sources, and otherwise it easily get messed, right? As you just said, somewhere you will declare it as integer, somewhere as socket num. So
no. It's a type def that I wrote wherever I wrote it. So if I want to have socket num as a return value from a socket call, I have to have it expected to have it in the same place.
Yeah. Okay, but in general, just I think that socket example is the worst example which you could brought from POSIX, because of it's basically derived from all Unix systems, and it's not really the language problem, right? It just was defined once, and we cannot change it anymore.
I'm not proposing to go change, like I'm writing a new language. Yeah. At some point in the world, there'll be wrappers to go to the different OS's native function calls, including such a socket. So you're going to live with the API from socket, and maybe I wrap some friendlies around it so you don't have such an integer conflict where I accidentally take a socket number and pass it in where I meant to pass in an option count.
Yeah, if we have different language, let's just use some higher level abstractions and stay away from all integers.
Well, right. And then you have a wrapper layer. This is what everyone does, right? Yeah. I mean, I think Java on socket's probably still using ints for all these things. But if I go to some other languages like Elm, they strongly type all these wrappers. You know, I'll say, oh, I have an option number for the open flavor or whatever. It's also typed as an int, right? But now I can't mix socket num and option nums accidentally. I have to try hard to mix them. Right? I have to cast one to another to force an issue. Yeah. Right. So that's right. Yeah. I'm going to have int as a thing. And if you mix arguments, if you mix values in different domains up accidentally that are all under the hood typed as an int, then you know you're screwed. And using a names type like that will help avoid that. Yeah, the only implicit conversion I'm thinking of is you'll go to the primitive type. You go away from a named integer to a plain integer. We could argue that one too. The other implicit conversion you see a lot of that I'm not doing is go to a string version. I haven't decided I want to do that one either. That's, you know, there's a thing that you almost kind of want to do is if I start a string expression, I want to have an auto call to toString, right? And you look at Python for stir versus REPL versus whatever, there's a couple of different variations on the thing there. But the auto conversion to strings is problematic. And under what context do you allow it to happen? Java does it if you have a plus operator doing string concatenation, he'll auto convert to string.
That was one of the things that I think it was Gosling said he regretted doing, was that auto conversion to string.
Yeah, it's convenient and error prone. So I'm on the fence. I use it all the time. It's very convenient. It writes tidy code when I'm doing debugging dumpers or nested toStrings, which are always debugging dumpers for me. They're always, how do I diagnose what the hell this thing is? Okay, pretty print it. Okay, what's the pretty print look like? Well, it's complicated, so I have a toString. All right, fine. And now IDE like pops up in toStrings for me, and it's all wonderful. And of course, accidentally you get toStrings, and then sometimes it doesn't toString when you expect it to. And so it's a little messy. Oh, dividing by an int. If sum is an int and in is an int, then I would claim that that division should possibly be a type error. I've seen double slash for integer over integer division returning an integer result. The other version of that is to claim that those automatically inflate to, because it's division, automatically inflate to float or to double, and return you a double answer. When does the conversion happen? Before or after the divide? Well, if it happens after the divide, you're fucked, so there's no point. So this should either be a type error or it should auto lift them both to doubles and return a double result. And now I'd go both ways a little bit.
Yeah, the problem is that the compiler has to know about all those types now. So
well, I know the type of sum and n and the result of a division. It's whatever I make divide. So if the divide operator says I take two ints and produce an int, then you have the usual round off that's questionable, like it's a code smell. So if instead I say divide op takes two ints and produces a double result of a double division, that's its definition. It's all fine, right? And if you want int over int returning an int and doing it as an int division, then use a double slash or some other unrelated operator. Or you do a double and you round it back to an int. Promotion to double, as well as type error, both seem reasonable. Yeah. Right. So I don't need the types anywhere. So, average is equal to sum over n, and then the only question is what type, right? I'm assuming that makes a double result because I don't want a division round off for integers except extremely rarely. So I can do that. I can do this. How about this, apples? Right? And now I've declared it an int, and I'd probably type error you and claim you have to physically round. You got double result from the division, you must round. So I'd probably type error that and say insert a round. And round is similar to Python. It's a constructor-like call. So that just takes an int and declares you. Oh, I'm sorry, not round. I'm wrong with thing. Sorry. It should be an int there. I can't go back and chat. So I have to redo here. Where int is a function call as a constructor-like thing that takes a double and produces an int by rounding. But that's similar. I think Python does that kind of thing.
it's the old style CCast.
Yeah, right. I don't like the other cast. So I'm opposed to that. And of course,
You're talking the space delimited.
The open close paren, right? I want to declare something long, except that typically the order of operations is incorrect. So I want to declare n to be a node, and I want to get a field out of it. I have to do double parens, once for cast, and then the second one because precedence is incorrect compared to dot.
Yep. Quite frustrating.
So I don't want to go there. So if I actually have to have it, I can't infer, because I'm going to infer if it's a sharper type than whatever you thought it was, then I don't need anything. I just do n.field. But if I have to have a runtime cast, it's probably going to be the other way around. It's going to be, it's going to be like this. So, and that would be the runtime cast to a node and then grab the field out of it. And the runtime cast can throw an exception. And then there's no other operator precedence issues. And instance of is the other brutal loser. Yeah, which turns null. Oh, if it's not. Yeah, I'm doing question mark colon things for, is it a thing? Make it a thing or null. And then cascading thing or null, thing or null, thing or null all the way through. There's a maybe kind of stuff. So I don't know what I want to do for instance of things. I haven't figured that one out. There's a version that wants to be a test, and I don't know what the right way to do that syntax is. So if I do instance of, which I'm claiming I'll never ever do, so this is ignorable. then here's a question mark colon, where after the question mark, I know your node, so I can go after field. So I don't have to cast again on the other side, but I don't like instance of. That was just like ludicrous. And if you're not instance of, you have to wrap a parentheses around and put a bang in front. So to do a not instance of test in Java, it's if bang in instance of node, then da da da, right? You have to have thing. Yeah, is. Maybe I'd probably want a colon in front of node to declare you a type. Let me go. Yeah, I don't typically need an as. I'm going to. Oh, I see. You're okay. I'll take a look. This is interesting. See here. So in is a colon node for a type. Like if I do this, I'm declaring a type, and if you're not, that's a compile error. But if I want a runtime error, I want to test. I like the is. I guess I like as is both short and obvious. So there's a pattern match is a different beast. But and if your pattern match is general enough, you use it instead of an if. So that's not a bad answer either. I haven't looked at pattern matches in the language. I intend to do it. I haven't got it in there. My first cut now is I'm doing arrays, and then when arrays are done and I've got looping done, then I'm ready to go do an implementation, and I'll come around and add pattern match as a syntactic sugar over something that's very convenient wants to be done. Yeah.
Did you settle on all left to right, or do you have precedence?
I have precedence. You know, add, subtract, multiply, divide, want precedence. So stupidly in the recursive descent parser, if you're in that point where those kind of Boolean operator shows up in the parse, I just parse until I gathered them all, and then I do a radix sort on their operator precedence.
Just because you don't want a billion 5-line functions, or what?
Exactly. And I'm changing the precedence around all the time, so I don't want to screw with changing the everything to get the precedence to change.
I measure my productivity in lines by code, so I'll go with the 5 billion methods.
Okay, fine. You know, it could go back to that at some point, but right now I just said, fuck it, I'll change the precedence 5 times in a row. So I'll just do a radix sort and be done. And I have, you know, funnier operators in funnier places, and things that look like operators, things that are operators that don't look like operators that go back and forth on whether they're going to be an operator or not. So for instance, square bracket for array is actually operators for containers. So a square bracket set is a function call in semantically in the language. The implementation sorts out the types and does the right thing. But if you have a dictionary, hash table, container class, then it's the same syntax, which means they show up as an operator, which means they show up in operator precedence tables, which means they screw around with exactly the issue I'm sorting today is what the hell is the precedence and the correct layering that I get the parsing the right way. So.
And do you have assignment as an expression as well, or is assignment separate?
Just for assignment has this other property that I declare on the fly as well. So only for the container classes does assignment, and it's not assignment, it's the square bracket equals. Here, hang on.
That's my question, yes.
That's an operator. At the moment, it's half of a balanced operator pair. So it's array bracket index. That's one operator to the square brackets with 2 arguments. And the other one is array bracket index equals val, which is a 3-argument operator of the square bracket assignment flavor. And I haven't decided if I love that or hate that yet.
Yeah, we did a single L value.
And the other option is L values
R value.
real, and then you can declare L values in the language and pass them around as L values. And then there's an L value, and in which case the left bracket makes an L value. It's a binary operator. It takes a container and an index and makes an L value out of it. And the right bracket takes an L value and produces the value out, or the bracket equals does the obvious, right?
And we used the ampersand because I'm just too attached to C.
I wanted to get rid of ampersand, so I got away from that. I'll find some other use for ampersand, but I'm not using ampersand right now.
Actually, the only two things we introduced from C were ampersand and oh shit, what was the other one? Oh yeah, typedef. Typedef is so nice.
I'm using typedef with colon effectively. You saw the assignment syntax. If I say, you know, typedef equals colon and a type expression.
Well, since we're fully reified, you know, you can have types that are thousands of characters long if you type them out. You know, so composing them with typedefs saves you a lot of code. And of course, you can always say var or val. So
I can add typedefs can appear on the right hand side of a type expression. So yeah, I can compose types. Odd infinitum. So function calls have arguments, arrow, result, and all of those can be typedefs, and they can be recursive. So, you know, you can have linked list, right? So list is assigned, is what's the right way to do it here? Is a list. Here we go. Colon next and a val, something like that, which just says. A list is a tuple where the first element's a next or field. Actually, it's not my correct field syntax, but it's a field containing a list and the val's the other side. Let me see if I can actually do this. This gets into if you have names. If you have round brackets, it's tuples. There's no field names. If you have this horrible angle curly brace, then you can have names on the thing, and it's actually the other way around. It's name colon list. This is the correct syntax. So colon list is the inside is the list type again, but it's always colon list. So the @ sign is my struct / class thing that just doesn't have name fields. It's a tuple with name fields. See line 36, 21. I haven't done anything with modules, by the way. So that's a whole other thing. I see module.x. What do we got here? Noble, and yeah, this is very much, yes, that's totally on the, I don't have an or type in the syntax yet, but it's totally a thing I want to do. I played around a lot with them.
Look at 31, and it's, because you were talking recursive.
Yeah,
so
map string, string doc. Oh, the typedef is your doc at the end. Yeah, right, there you go, exactly. So a doc can be an array of doc. Yep,
well, that's JSON, that's JSON's spec right there in 2 lines of code.
Yeah, fine. Yeah, we had to have arrays show up somewhere and map, obviously. Fine. Dun, dun, dun. Yeah, union types for, did them with Elm, and they're just so freaking handy. Union descriptor up front and then variant fields afterwards with an OR bar, and then you go to the match. So this is talking about matching. Absolutely, you go to the match and you break it out according to the different union types and all that.
And one of the most handy things that I never anticipated. So obviously you have like intersection. We talked about this once before, where you have like intersection means 2 things. It's like this type or this type. So pick one. It also means kind of that over the small area of overlap between them. That's the real math intersection, right?
Yeah.
But then there's this other one, which is AndNot, which is it comes up all the time. In type algebra. So in your if statement that you were talking about a minute ago, it's 5 minutes ago, you actually had that example where you said, I check this, right? And then I know it's going to be that field, that .fld is on there because I checked the type.
Yeah.
But the cool thing is the else side of that knows it's and not the first type.
Yeah, I know that.
Right.
Do. So in particular, if you do a null check, then you're null on one arm and you're not null on the other. And
that's right. So you know all that internally, but the question is do you allow the developer to write and not?
For null, I do.
Mm-hmm.
For a 2-element union where you have a discreditor or whatever, an if test up front, That was totally going to be there, but I haven't gotten there. But that's easy. To do it in a general way, I probably will. As soon as I have an or discriminator, it's very easy for me to start knocking things off. If you do a series of if tests in a row, I'll just knock off the parts.
So we don't have an AndNot way of saying that easily. So I've actually been trying to think, because it comes up so often that I'm actually thinking, that belongs as a first class. Anyway,
I hear you. Right. I mean, you get it implicitly as soon as you run through the other side of a test.
That's right.
And my typing system totally gets the tests and totally does that game. But I don't let you declare, I haven't thought about letting you declare subtypes of a union type that I'm only the following, and then the typing system is certain. I'm inferring, so if you're wrong, I'll just tell you you're wrong. But the question is, can you describe even the test you want to have? And that's what you're proposing. You should be able to say, just these pieces and not those pieces as a descriptor, because I want to verify that. Question, Fanny, reminded me of blah, 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 fun plus xy, if x is z, then y else s, da, da, da. What the hell is this? Case z, this is
So that's a Bob Harper's essay. He wrote about this common thing called Bullion Blindness, that when you have that's pretty much Cameron's question. When you have an if statement and you're testing on a bool, and then you have some branch that can be one type and another branch when the expression can be of another type. When you use an if statement, most of the time you completely destroy that type information. And then later on, you can heroically recover this, of course, using semantic analysis and traverse the AST, analyze types, etc. But you don't have to lose it. You can, for example, in pattern matching, you can use type constructor for different types in different branches. And those branches do not have to be homogeneously typed. If you have heterogeneous typing in the branches, you just never lose that information. So the type system may seem fancier, but on the other hand, the compiler construction is less complex, and more precise typings mean you don't have to recover anything. You just have it in the first place.
So the Elm syntax pattern matching will totally take the union types that Cameron is showing off and break them out.
Yeah, exactly.
And know each of the arms has that type. And I found that very, very useful. So that's definitely a thing that I'm going to be doing. I just don't have a syntax for it at the moment. Implementation-wise, I think it's...
You just haven't found a syntax you like that's terse enough for you.
No, I'm actually out of time and energy. I just haven't had time. Oh. There's a terseness as well, but the typing system I have under the hood will support this level of resolution sort of straightforwardly.
Yep. Yeah, actually on our internal type object, we actually have a method called AndNot. And it gets used everywhere. And it's like, I was just noticing the other day, it's like, why do we use it internally and not have it surfaced in the language? So.
I see. All right. Yeah. Well, that would be one more piece of weight in the evidence pile saying do it, but it was kind of in the works already. Certainly the pattern match with the union types is in the works. Having a say it specifically thing, now I'll go do something with that.
And do you have Elvis, I assume?
It's one of those. It's in the works. Show me which Elvis flavor you're looking at. But I'm just out of time. But the typing system totally. I use question mark colon for if then else. So when you say Elvis,
so you can say, let's say that A is a null or a string.
Yeah.
You could say, for example, you have another one. You say, you could say like. You could say this is an expression, right?
Yeah.
So it says either A, if it's not null, or use hello.
Yeah, okay.
I don't call that the Elvis operator.
Right. I don't know the language now. I've seen that used before. The Elm version of it was too syntactically heavy. This was their maybe operators, where you had a maybe thing, and you could just pass along the maybe to bury underneath the null or not. And if anyone failed out as null, the nulls in the end. Otherwise, it was all not null operators down the line. Right.
And then there's what they call the Starship or the Star Trek operator. Do you remember the old ASCII Star Trek game?
Yes, I've written them.
So that was the symbol used for the Klingon, I think, or something. Anyway,
one of the spaceships, yeah.
Yeah. So, but that one returns a signum.
Oh.
So, so instead of having two comparisons or whatever, you know, so you have an equals comparison, you have a less than comparison, you have a greater comparison. Well, this one returns a signum.
Right, right. The other one I wanted to see is the three-way compare for a range check.
Right. And that one, there's a Wikipedia article on that. It's been a couple years since I've read it, but there are languages that have that one.
Yeah.
Yeah.
Is it syntactically ambiguous in any way, any reason? I would claim it looks very much like my balanced operator bracket game. As soon as I have the left and the right, I can pull out the trinary and say, it's not a Boolean operator in an expression file. Like a standard expression is some atom bool op ad infinitum. It's not an atom here, it's a fact, which whatever, fine. Okay, it's not that, because you have three exactly, and also one of the first pair by themselves would normally parse out as a bool. So you want to catch that case special. So it's funny in the parse syntax somewhere, but I like using them.
I'll think about that one, because that I can certainly see in C-style languages that being all sorts of headache because of the left to right expression analysis.
You have to figure out where it lands in your parse syntax. But I have so many places where I just do a range check, and I end up saying,
yep,
if and x less than high, and I'm like, why do I have to say and x less than? Right?
And then there's that, of course, if you support
ranges, intervals. Yeah, I haven't figured out if I'm going to do anything with intervals or not.
Well, you could compile it the same way. It's about readability. So which readability do you prefer? Because you can certainly make the first one work. The question is, how many other things do you have to throw off the bus to get it?
I like the first one over the second one, but yeah, right, exactly. I don't know what I have to throw off the bus, exactly.
And would it always be less than equal? It would sometimes be less than, and sometimes less than equal, right?
Yeah. I would demand they be in order, but less and less equals would be, you know.
Yeah, in that case, if it's only less than and less than equals, it's pretty easy from a parser perspective, because what you do is you have a whatever you're on your recursive descent, whichever one handles the relational operator, you say, you know, parse expression, and then for your branch where the relational operator is less than or less than equal, you then say, you know, you peek for the next token. You say if it's less than or less than equal, then you apply the special rule.
Yeah, okay, fine. And that's my general.
I may steal that idea if I like it.
There you go. Well, I think you just answered my question though, and then the expression, which are normally expression expression bin operator, expression bin op ad infinitum, stops exactly at 3, and if you have more afterwards, that's like a different error. Although honestly, you could stack them as long as they're all cooperated on a less than or less than equals. I could stack them ad infinitum, but no other operators, because then I would claim you're not a well-formed expression. Fucking throw some parens in there and be done. Yeah,
you generally want to write your rules in such a way that what you just wrote there would be illegal unless you are explicitly supporting it. Because the more things that are illegal, the more variability you have in your parser to do special rules like this. So when you're infinitely composable, like C, for example, where your equals is an expression, so now you can have assignment with an assignment, and you know. So when you're infinitely composable, it actually makes the parser's flexibility, right? Well, you have to have some of those rules, right? But you pick the ones you want, because the less infinite composability you have, the more ability you have to add special rules like this. Like for the same reason, parser writers, language designers will say, you know, semicolons are not a bad thing because they're explicit. Even if you could figure it out on your own, having it like helps, for example, the error recovery.
Helps error recovery.
Yeah.
Yeah, I'm you know, semicolons are between and optionally at the end. So
yeah, I mean, I still use periods when I write English.
Exactly. Yeah. Yeah. What was it? Question mark colon. Yeah. You're saying as a token, just as a what's the token assignment flavor mean? Your Elvis operator for assignment.
So A op equals B. usually comes to A equals A op B,
Yeah,
right?
right.
So A Elvis equals B means if A is null, steal the B for A's value, otherwise leave A unchanged.
Okay. So you're saying this maps to something like if A is null, I'll just use the
A equals B. Exactly.
If A is not null, use A, else use B. I'm going to claim something like this. If A is, this is a null test on A. If A is null, return not null, return A. If A is null, return B. Is that
right?
Like, imagine using a C. I wrote some C code there.
Right. So that would be without the equals. The equals says assign it. So A question colon equals B is the same as saying.
Okay. So
if A equals null,
this is ugly.
then A equals B.
Yeah.
Right.
Yeah, the if assignment is what is the expected. Yeah.
So it compiles to a JNZ.
Yeah. Conditional move or whatever. Right.
Right. Yeah, that's right. They've built it into an op now, haven't they?
Yeah. Vaguely useful in the compiler because the conditional move moves it from control flow to data flow, and then it can reschedule a little more conveniently around other things.
You have to remember, I learned x86 assembly when it was still the 8086. So.
Yeah, I started there, but I kept on it for a long time.
I noticed.
Yeah, I got away from it after a while, but it took a long time.
Are you going to get back? Are you going to use LLVM?
I'll probably do some. We'll see. I'll probably do some assembly here. I mean, I haven't figured out what I'm going to do for backend. The first obvious backend is I'll just go cough up to I'm writing myself in Java right now, so I'll just back up to Java, to the JVM. After that, there's the get a heavyweight fast backend like LLVM, or do a self-hosting game and just start emitting some dumbass assembly, for which I want to type assembler what I want to type assembler anyhow. So I might actually go write a type assembler in AA and then turn around and write a first cut AA to dumbass.
Yeah, that's the reason I didn't use.
No, target Itanium I did. Literally, I did the Itanium target for hotspot. So no challenge.
Well, I specifically avoided using like WASM as an intermediary because it's a very weakly typed assembly. So.
Right. No, you just use WASM as something. The other option for the backend was not WASM; it was JavaScript.
Mm-hmm.
So I could go run. Yeah, thank you very much. And for literally a year, I had a fucking Itanium under my desk at Sun, not Oracle, where like a ginormous space heater blasting away the huge loud thing.
Kept your toes warm.
Oh my God. And of course I had afternoon sun come in my office too. It was just like miserable. Fine. Yeah, it had its weaknesses, it had its strengths.
And remember that
for everybody register, but other things were miserable.
And remember that that's a modulo, not a remainder.
I'm kind of there are a bunch of operators that I'm like hoisting away from the standard language because they're not used enough to like deserve, like Zor. Like I grabbed Zor, like the hat. That operator, I'll probably leave % as mod, and whichever mod it has to be. But hat, I'm not. You want Zor, you're going to ask for Zor by saying Zor.
So we did a div mod, which is actually div rem. So if you want the remainder, you do it as part of the division.
But why? Okay, I understand. But why at the language level? Now, the compiler wants to JIT it that way, typically, if you're doing it that way. But the language level, do you really need both pieces written out as a shorthand? My theory on language is special language syntax is only for things that are commonly done in a language. And I claim getting a div mod remainder out is not a common operation in a language. You don't write a lot of code where you use a div mod.
Well, my point is you never write code with div mod, you write it with div rem.
Well, div rem, I don't fucking care, div rem.
So,
you don't write a lot of code with div rem either. You write a lot of
I
code
do.
assignments, it says lookups and arrays, the hash table this, and virtual call that, and blah, blah, blah. You do not write div mod, div rem, any of those things very often.
Okay, so that's the mod, that's the div rem, that's the modulo, and that's the divide.
Okay, you're throwing it in for completeness more than anything else.
Right.
I'm asking why have a special operator for such a low frequency event?
Because it doesn't cost anything.
Well, it burns another hole in your language spec somewhere. Fine. Maybe. It's not like it's going to be confusingly written. No one's going to accidentally write it. Like, how about assignment inside of ifs? Right? Do you do anything special? There you go. So it's about confusion, common confusions. Right?
Assignment,
the whole,
with an equals inside of an if?
Yeah. If x equals null, right? I only put one equals.
That's a syntax error.
Okay, so sometimes I actually want that because I have a complicated thing. Temp equals blah, 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 blah is unequal to null, with temp, right? I want to.
I have no regrets for making assignment not an expression.
Okay. For
almost
me,
no regrets.
Expression, but inside of an if thing, I've been back and forth on I'll demand extra parens or I won't, just to make you not accidentally do it.
So what we have two kinds of assignments that can occur inside an if or in an assert or etc. And the one is, let's say I have some type T and there's a method called foo that can return a nullable result. So what this does is it gives me a T is of type T inside the then branch, and inside the else branch there is no T because foo return null. The other one is with a conditional, what you could think of as an optional, I think some languages call it.
Yeah,
so
I have very similar syntax for a very similar reason, except you can skip all the type.
Yeah. Well, we're not into terseness.
Well, you can add the type in too. The type if you want it, type if you don't.
Or we can say val or var if we don't want to type the type. But in the second one, what bar returns at least two values, the first of which is a Boolean. So if it returns true, then the second value has to be of type T, and if it returns false, like the null case, there's nothing in the else.
Yeah, I would claim if I'm going to return multi-values, especially for error codes, I'm going to demand them come in as a tuple.
Well, like in the case of iterator, instead of having has next and next, we just say continue. We just say that's the method signature, right? So it returns a conditional T. So think of it as a tuple that either has a false or a true and another value. A true, sorry,
Yeah. This would be next is typed as a function which takes something, I don't care what, and returns back a Boolean and an E, which is whatever your next element is.
Right, but you're allowed to do that because your E can be null, because you kept null as the subclass of everything, right?
Kind of.
Yeah, so we can't return a Boolean and an E when there is no E to return, because null can't be an E.
Okay, and so in your first example of if, T would be available. So
only
if I say
in the then branch.
T would be available as null. So do this, and then I can use T here, and the other arm T. In the first arm, the ... T, use T is usefully and type whatever foo types it as.
Right.
And the second arm T is guaranteed a null.
Right. Exactly.
Yeah. It would be available as a null. Yeah.
Yeah, as you know, I have an aversion to the.
No problem. We've agreed
null
to
subtypes
here. It's all good.
But yeah, that makes perfect sense.
Yeah, I don't have a way to break down a Boolean tuple inside of an if and then behave on it. In your colon equals if example, I instead said that I had, Boolean, I'll call it P here for predicate, and E was assigned the result of bar, and then I would say, P question mark use E. I got to type out here. I'm typing aloud, and then whatever else things go off here. I'm missing a colon in the middle there. See if I can cut and paste it. But basically, I would say the first part is take bar and throw in a tuple, and then test on and branch left or right. And
so the other thing we did in C,
both, and it could be typed differently in both. In one, E could be a real value, and the other could be an error string.
in C, that's an expression that has the value C.
Yes, I have very similar syntax for the same.
And boy, I hate that. But
not identical.
So we drop the equals as an expression, and we drop the comma as an expression. But what it lets us do is have on an if, we can say if A, B, C, and it says if they're each a nested if. It's like saying if A, then if B, then if C, which is actually quite handy.
And what's the difference between that and? I would
because
say.
not everything's an expression. So for example, I can declare a variable in A and then evaluate it in B and declare another variable in C. So
I can declare, and expressions for me are just normal.
Yeah, well, you get to do declares anywhere. So
right,
that's not a big deal for you.
Okay, fine. I get it.
But it's handy because now in an assert, you can assert that includes a declaration, because in assert, the syntax is the same as an if, right? Yeah. So if the assert passes, then that declaration exists, right? So you don't have to declare something and then assert it. Oh, and our asserts don't, our assert by default doesn't get compiled out. So it actually is a runtime assert.
Okay, so it just has it has a behavior if it fails, that's stop and throw an exception.
That's right.
Yeah. For me, if you can have a declaration appear inside any expression anywhere all the time, that's fine. So any expression which is going to throw out if it fails, and I'll have a shortcut for assert, and I don't right now, but I will. It'd be the same behavior. One that would be compiled out would only be one that had some sort of default.
So you could use the XOR symbol for your assert because you don't have. You could use the XOR symbol for your assert because you don't have XOR anymore.
No, I have the XOR symbol used for early function exit.
Oh, well, an assert's an early exit.
And it is, but it only goes one layer.
Yeah.
Only goes one layer. So there's another version of that which says I want a thing that early exits all layers until there's a catch, but that's an exception. For which I'll probably do something a little different. I don't know what. Bang somehow, but bang's the not operator, but there's a usefulness for bang, meaning, hey, exception.
Yep.
Don't know what the right way for that one is.
I think we set a new record on this thing going long.
Oh, here we are, 2 hours. Oh, shit. Well, we got excited talking about language design choices. See, I wanted to have a language design choice conversation for a long time with you. It's just, this is a rare and far apart, but this was a good one. There's a lot of ground we covered here. I have to go back through and stare at things, divides and a bunch of null things and a bunch of Elvis operators and Star Trek operators.
So I really like your range check idea, and I'll tell you why. One of the things that we have as a pattern in our style of development is that if I write something, even if it's wrong and someone else catches it, the assumption is there's a reason why it was written that way. So it's wrong, but why did it get written that way, right? And there's a couple times where I've had a compiler error where I wrote my range check as you wrote it. And now I'm wondering, well, if I've actually done that many times, maybe
there's a reason that you should just do it.
I need to think about that one.
Yeah, think about it. Like I said, I've used a language somewhere. I want to say Python. I don't remember. Some language did that conveniently as a syntax choice. Maybe it was R. Some language did it. It was freaking convenient, and it was expressive. It unlike your in of a range, the in of a range thing, the nested sequence ordering. It's very obvious what you mean, right? This was like, I get what that's trying to tell me. And it could be longer, it could be 4, 5, 6, but everyone's clearly stating an ordering preference. And it's very understandable what it means. So I think I was just hunting around where to throw it in the language, and I think you answered my question of where I'm going to jam it in.
So I'm
Yeah,
sure
that's
you've
a
seen
range
things like that.
operator for loop,
Yep. So
which I've
that's
been
one.
screwing around with for loops and what I'm going to do with that.
Now, that's usually an off by one because it's usually supposed to be like this, right?
Depends on whether you want the right-hand guy to be exclusive or inclusive.
That's right. So
you have to decide now and make it obvious. So,
look closely.
Oh, no, I'm not doing that. I hear you, and mathematical, blah, blah, blah. No. My Emacs will hate your guts for doing balanced print matching forever and a day. I will not do that one.
What is Emac?
What is Emacs?
Is that like a new Macintosh?
Yes. No, it predates Mac. So yes, the Mac is the new Emacs. No. Every IDE on the planet likes to do balanced parens.
I hear you.
Complain when they're not. And I will get every complaint on the planet here, and I will not do this because I don't want to try and sort it out in the IDE. Emacs has very clever pattern matching where he has separate pattern match blinky paren things if you have the brackets in quotes or in comments.
Mm-hmm.
He will bracket them within quoted string. So if I do something with a printed and I'm trying to print a quoted string and I put a square bracket in the one string and another bracket down here, those will match independent of the C matching
Holy
around
cow.
it. Very convenient. Very convenient. Sorry.
Someone with too much time on their hands, I'd say.
Somebody 20 years ago, too much time on their hands, and I just inherited it. It's like, oh yeah, this is nice.
So in that string, if you escape another string, will it then do it nested inside that one as well?
It's pretty good. He knows about string escapes. So I don't know off the top of my head right now, but he definitely knows about string escapes. He does handle languages where you pop back and forth between strings and escaped into the core language and back nested, and he does balance them correctly. I don't want unbalanced brackets for anything because of the pain for IDEs. So I'm not going to do that for open intervals, Matt. Instead, I would claim I want a for loop over not an interval, but over a collection. And now I want to have a syntax separately. I want a syntax that says, I want to count from I equals blah to blah via blah for blah. And I want to have, hey, I'm iterating over a collection. And furthermore, over the collection, the default iteration is unordered and can be parallel, for instance. Yes, so Emacs will do square, do angles, do curlies, do round, all of them balanced in quotes or not in quotes, and nest them properly as you quote and unquote as you go. And like I said, that's terribly convenient when you're staring at trying to write printers for balanced structured things to go have them sort on that for you. I don't do your other case here, Mark, where your language does escapes that are full blown, but I know Emacs does that, but I haven't tested myself. So yeah, so I have a collection thing. So let's say I have a collection called, I don't care, ABC, and I want to have an iterator over the contents. So at this point, it's just going to be actually the shortest syntax is just this, which says apply a function to a collection where you take an E and you do something, and you'll get back a collection with of the map call. And that's roughly equivalent to ABC, comma, and has some function to a map over an ABC. And I'm going to have a reduced flavor of that as well. So you get a map and a reduced flavor. That's separate from a for loop, but I don't feel the need for a for loop where I have a range which is integer only. You're just going to have something that looks like, and I'm not doing the right syntax here. You're going to have something that looks like I'm counting and fucking in C, right? I : = 0, I less than 100, I plus. That's not my syntax, but that's the right thing. And my phone just dinged, and I'm backing off here. But all I'm saying here is the number of times where I need an integer range independent of a collection is rare. Now, you can argue that it's common enough, it should be given a special thing, but from my opinion is, I have collections, I want to do a collection thing. If I don't have a collection, but I do have a thing I'm doing with integers, then I'm just going to have the spelled out version and not do a range and now argue me against it. And I can listen. I was just like, my experience is I get one or the other. Sometimes I have mismatched collections. Occasionally I have mismatched collections where I'm iterating between them at independent rates. But then I'm just going to have an iterator that's stepping independently according to what it's doing. You're doing a merge sort. You're picking two sorted arrays and you're merge sorting them. Well, you got an I and a J and they increment independently, and their output goes to some third thing somewhere in the world. But at that point, the iterator is complicated and give it up, right? There's no language shortcut. So right now, my for loops are all done with smalltalk styles, block expressions. And you say for, and then you hand a block for a predicate and a block for the body. And I rerun them both until one of them says give it up. And you can get a value out of a for loop. That was a key. So I can do a find and a for loop and return not just I found, but what the thing I found was. So you can abort early out of a for loop with a thing. Yes. Yeah. So right.
So what did you mean by that last comment?
Okay, Matt has a thing that matters that I have an answer for too.
Okay.
A for else or something. So like I want to write a for loop because I'm looking for a thing and I want to break out with the thing. So if I say fine, I'm going to the integer index of I'm getting there. If, predicate of a sub I, and then you'll see here, then I want to break. So I want to have a way to say, find the first filter element of array A, give me the index. In this syntax, I's lifespan ends at the for loop. I don't get I out. So I don't know if I ran to the end and I failed, or I found an element. So I can put I outside. So I can say int I, and then I can say for I equals 0, I less than 8 out length, I plus plus, if, pred a sub I. It's hard typing sideways and without my IDE here. And break, and this gives me an I, which is length or shorter if I got a hit. But I had to put the I outside. It was kind of obnoxious. And maybe I wanted to return the value that I got instead of a sub I instead of the index. In which case, how do I return a value? Well, I have a variable declared outside the for. I assign it into a break. So the break now becomes a complicated curly bracket thing and da-da-da. So for me, the syntax is a little different. It's although if I want the index, I'm still going to suck it up, and I don't like this. So I'm still sorting on it. For takes two functions. There's a pred I less than 8 out length. Let me put the plus plus here, and the body is pred, which this. So the difference here is the first function. If it returns false, I abort with a false for the entire for loop, and if it returns true, I continue. Same as a if test on a for loop. And the second expression at this point, this version of it says, if it returns false, I continue. If it returns a truthy value, I return the truthy value. And the only false value is nil, and everything else is truthy. So you'll get the element out, or it'll loop until the predicate blows. And the thing I don't like about this one is I have to have I's scope exceed the scope of the other two functions. So there's another version of that where I declare I internally to yet another function layer for the for loop, which would give me the C scoping rules for I, which would be this version. And then I have to have a way to have two functions, but the for loop wants them both. So then I have, I'm going to return a tuple of functions here. It's not as pretty as I want, and I don't like this yet, so I'm still going at it here. Where's this one here? Pred sub a sub I. Da, 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 da. I might have not got my parens balanced correctly. I surely did not. That's not a good I don't have the parens balanced here. So, oh, I see where I missed. That's fine. I'm trying to return a tuple of two functions. The first one's a predicate, second one's the body. But that gives me an I scope that ends at the for loop. So I don't have to deal with an I living past the for loop. But I still get to return the predicate I found. If I want I, then I need to have it outside the scope. Although I can actually return it. I could return it directly there. Let me clean up the syntax a little bit here. Of course, I'm writing it in one line, and I wouldn't write this code in one line either. But so then I have no balance paren matching here. Square bracket, round bracket, curly bracket, round bracket, curly bracket. No good. Need balance paren matching. That's the same thing. Just oh yeah. Oh, you did what? Enter, control enter or something to give you a thing.
Oh no, I just pasted it from some code.
Okay, there's a way to do it. So there's probably control enter. I can break this out. Yeah. So I don't like the second version, although it hides I. The first version is the sort of nicer syntax, and I would put the predicate body down on a lower layer. So let me go do that using control. And
I mean, the other thing you can do, Cliff, think about it this way. I'll write it in my own thoughts.
Yeah.
Sorry, forget the end of that. If you treat for as a function.
This is syntactically identical to what I wrote before, but it looks a little nicer. Right. Okay.
If for were a function, it could return the values you wanted.
For is a plain ordinary variable, which happens to be assigned a function which takes two functions.
And what does it return?
It reevaluates the two functions according to a for loop semantics and returns either the null if the predicate fails or the truthy thing if the body returned a truthy thing. So for is an ordinary variable in the language. I have a standard AA syntax for its definition.
And so where does the predicate actually go in this case? Because that gets returned, right? The A gets returned, right?
I'm sorry,
you test the A sub I.
Yeah. So in the loop I wrote, if predicate returns true, I'll get a true out as opposed to a value. If I want to return a particular value, I have to exit my function with that value. It's the last value in the function. So if I actually want to return something else, let me redo this.
So you'd question question that and then say A sub I colon false, right?
Yeah. Let me. Here we go. Yes. So and then if it's true, yes, so return I. That would do it because the colon operator takes a default :0, which does the right thing. And the other option is I could do a hat somewhere in there to exit early with a particular value.
So you don't even need the I equals 0. You just need the I equals 4.
If I put I equals 4, the loop would start at offset 4, at I is 4.
No, I meant, I see. Oh, because that's your counter.
That's my counter.
Because you want an answer.
Yeah, if I want an answer out, which is the index where I found the predicate to be true.
Or the thing that you found, right?
If I want the thing I found, instead of returning I return A sub I.
Right.
Yeah.
And then you'd have some declaration in front of the for that says, some value V equals.
Oh yeah. Whatever I'm going to do with the expression. It's an expression. It can sit inside an argument list for a function, further function call. It can be assigned as a something or whatever I'm going to do there. Yes. It's totally an expression. For loop is an expression. It returns a value. And I could assign it as V equals. And the assignment of I to 0 is the default. So, so there's this version, which just says I is 0, V gets assigned the result of for loop to doing what it's going to do.
Right.
But I have to have a declaration of I outside. Otherwise it doesn't.
Otherwise you don't keep it. Right.
I don't keep it. Yeah. And then on the pred in the inner, in the body, I would be undefined and I would get an undefined error. In the body piece. Actually, it would get undefined in the ++. If you assign an initial value or you declare it without an assignment, it gets declared in the current scope. Otherwise, if the first action is a read, The read will look up scope. If it finds it, that's where it got it. And now it's what you have it for the rest of the scope. This is a Python-like syntax for globals versus not the globals.
Mm-hmm. Cool.
All right, I'm starving. We're at 2.5 hours, not quite. I see some hardcore hangers on here. It's a lot of fun, actually. I don't know what my Zoom bill is going to be. They're going to like blow me out here. But hey, this is good. So till we meet again, I guess. And we can go back around the language hacks because, like I said, for loops are still a work in progress. They're far enough along. I'm moving on to arrays, but they're still a work in progress. And so I'm happy to go back and forth here on all of these things.
Yeah, interested in seeing how it progresses.
Yeah, me too. It's like fun.
DLS
Yeah, DL scheduling language. Oh yeah. Let's talk about scheduling languages. Yeah. So every C compiler I worked past the 90s took the standard, and Java does to a fair extent, believe it or not, C2 does stencil calculations by doing the obvious unroll and jam and grouping all the right loads and stores. It does all the right stencil things, does all scale replacement, and ends up with scheduling. It does a hardware pipelining scheduling operation that's modestly good. I did it for Itanium, right? Itanium had to have it. So I'm not claiming you couldn't have a custom DSL language here. I'm claiming that if you're writing simple enough array math, Java can do pipelined array unroll for Itanium, for instance. Separate scheduling language. Oh my God. Yeah, and as soon as you got too complicated, of course, what I was doing wasn't gonna, I did the standard obvious pipeline loop unroll thing where you just did a unrolled loop and filled scheduling slots, and then you tried to wrap them around, but I didn't do a smart unroll other than on enough size.
So basically you were doing what the
So basically, think of scheduling not only on the microarchitecture level, but say, think about graph traversal. If you were to write a loop for graph traversal and you wanted to switch between depth first versus breadth search versus batched DFS versus batched BFS and different size of batches and chunks and different vectorization of these and different parallelization with different scheduling. If you have a good scheduling DSL, you can do this in one liner. And it doesn't matter if you have your data in as a structure of arrays or as an array of structure, you can easily optimize from one data structure to another too. This is very, very hard if you're doing something as low level as a C-style loop when you're indexing index by index by index, because this is essentially manual addressing in a sense, because index is just address and it's address by address by address, and it's just passing pointers around. But slightly higher level here may actually help a lot, because you can enable a lot of very, very fast optimizations, different vectorization, parallelization.
Which is what the C++ iterators try to do now, right?
No comment.
I didn't say prettily. I said it's what they try to do, right?
I'm not there. I'm going to make convenient ways to work with collections.
There is actually something interesting in the C++ called executors. So this is essentially for things like switching between vectorization and parallelization and nested vectorization within parallelization. So C++ has already this separation, which I think is actually quite good, between algorithms and containers. So if you have an algorithm like accumulate or inner product, or you think of fault and reduce, this can work on any container. And that container, when you are designing this container as a class writer, it completely doesn't matter what member function this container has. And this is a good thing. So you, as a container class author, never have to worry about whether someone is, say, going to hash your container someday or not, because this is not your responsibility to be providing every single method for every single algorithm use. And what iterators here, I think, has done well is to basically solve this problem as another layer of indirection. So you go through 3 layers. You have containers, you have iterators, and you have algorithms. And because containers always provide iterators through begin, end, and advance, you can connect them to any of the hundreds of algorithms. And now if you want to build, you can build on top of that. And executors are essentially the optimization strategy for algorithms working on containers. Because now that you have that layer, you can also parallelize, for example, on the dispatch it to the task scheduler. And that's the part that is currently work in progress. But I do think it's interesting. I do think this separation is one of the things that is quite unique in C++, and that I think is quite well. Even if iterators may still need some improvements, I think the separation between algorithms and containers and not stuffing them as member functions or methods, that was a good idea in retrospect.
All right, we have our reading cut out for us here. I will take a look at your reading list here, Matt. Okay, all right, I'm gonna go eat. You guys keep going if you want, but I'm gonna end this anyhow, so sorry. Next week, this is good. All right, goodbye.
Cheers.
Good weekend.